Good afternoon, everyone, and welcome to this special session of the UNIGIS International Academic Excellence Award. It is a great pleasure to open this event where we celebrate some of the very best master theses produced across the UNIGIS network. This award recognizes outstanding academic achievement, innovation, and the impactful use of geospatial technologies. The work we highlight today reflects the diversity, quality, and global reach of the UNIGIS community. This year, we are proud to present one first prize and two second prizes selected from an exceptionally strong pool of candidates. These awards not only recognize excellence, but also the potential of these graduates to contribute to the future of the geospatial field. In today's session, each of the winners will give a short presentation of their work. This will be followed by a question and answer session where we invite all participants to engage with the presenters. I encourage you to listen actively and take this opportunity to learn from their achievements. With that, let us begin by introducing our award winners. Our first presenter today will be Christa Horbach. Christa was a student at UNIGIS Salzburg. Christa graduated in geography with a minor in biology from the University of Bern and geoinformatics from the University of Salzburg. She works as a GIS project manager in the provincial government of Canton Solothurn. Her passion for working on complex and interdisciplinary problems led to a master's thesis on sequential least cost modeling to uncover the expansion dynamics of an invasive bee species. The research was published in Landscape Ecology. She developed a thesis entitled Leveraging Least Cost Modeling to Uncover Multiple Introductions, a case study of an invasive wild bee species. She was the winner of the second prize. Let's hear Christa. Christa, the floor is yours.
Thank you, Marco. As Marco already said, I published my study together with my co-authors Gudrun Valentin, Julia Lanner, and Jovana Bila-Dubaic. I wrote my master thesis in the form of a manuscript-based thesis. That means I wrote a paper which was more or less ready to be published, and along with a work report. And as we published that, I allowed myself to use updated material from the paper in this presentation. Now, let's get started and say hello to the sculptured resin bee. This is the exact bee which inspired me to write this thesis. One day it showed up on my balcony and built its nest here. And I ran a Google search and found that this is an invasive species called sculptured resin bee. I also found that in Europe, researcher Julia Lanner is researching on its expansion dynamics. I contacted Julia, and this is how everything started. Speaking of invasive species, it's important to know that they are a major driver of biodiversity loss. That means they are causing the extinction of native species. If we want to do something about it, if we want to develop management strategies, we need to understand their spread. How do they spread and how fast do they spread? It is also important to know that invasive species often arrive multiple times in a new region. They're introduced multiple times. To detect that, to know that, usually genetic methods are required. But genetic methods are labor-intensive and expensive. So very often expansion rates are estimated assuming that all observation records in a study area belong to the same population originating from one introduction event, just because we don't know better. That brings me to my goal. I would like to fill that gap and propose a data-driven spatial-temporal method instead of a genetic method to identify distinct populations and then to derive expansion rates for each population. My study species is the sculptured resin bee you have just seen before. This is an overview of my methodological steps. We will dive deeper into that in the next few slides. Every analysis starts with input data. And in the case of least cost modeling, this is point data, which in my case consists of observational records for the sculptured resin bee in Europe. And we also need a raster, a cost surface. In my case, this is an environmental suitability map. This map shows how suitable a habitat is for the sculptured resin bee. The key steps, the methodological steps, are then sequential least cost modeling, followed by delineating populations, followed by distance regression to calculate expansion rates. What happened to my presentation? This is not what should be seen here. I can explain using this one. So I would like to talk about the first step, sequential least cost modeling. Least cost modeling is a method to connect points of interest with an optimal path or a least cost path, or also called a shortest path. In my case, I applied it sequentially in annual time steps to connect every observational record with the nearest known observational record from a previous year. By doing so, I kind of reconstructed dispersal paths. The next step, the population delineation, works as follows. I removed all paths with an extremely high accumulated cost, so to say the longest paths. And this effectively isolates the remaining least cost paths, which allows me to assign population IDs to all observational records. In the next step, the distance regression. This is just one method. There are many available methods to calculate expansion rates. This works as follows. You have a point of reference, which is the first observation in the population. Then you calculate the maximum cumulative distance for each year, and you regress that against time. So if you look here at the bottom, on the left, on the right-hand side at the bottom, you see on the x-axis the time steps, the annual time steps, and on the y-axis the cumulative distance covered by the advancing invasion front. Now I need to skip the broken. So, now yeah, this kind of works. On the left, no, this doesn't work at all. That's a problem. Can you zoom in? No, I can't. Well, let's try. Here you see a map showing the least cost paths assigned to least cost to populations. We identified 4 populations which we consider robust enough to be considered for further analysis, to be considered for expansion rate calculation. These are the 4 which are colored. We have one in France, one in Italy, one in Austria, and one in Serbia. The expansion rates range from 13 to 59 kilometers per year. Now, there's a graphic missing. Maybe I can... This is becoming a real problem. Yes, so the graph you see showing the cumulative... Can you read it? So here you see, at the bottom, you see the graph. At the bottom, you see the graph showing the cumulative distance over time. If we now look at it closely, we see that there are three distinct temporal phases. We start with a slow initial phase, an accelerated expansion phase, and a slow final phase. These phases are also called lag phase, expansion phase, and saturation phase in biology. And if we apply the linear regression model to the expansion phase only, we get expansion rates of 82 kilometers per year, respectively 90 kilometers per year in Italy. So lucky me, in my case, there was genetic analysis available for parts of my study area. There were genetic samples analyzed from 4 sample groups. The sample groups were in Vienna, Switzerland, France, and southern France. And the authors found that one genetic group consists of the Vienna samples, and the other 3 sample groups form a completely different genetic group. That aligns very well with our findings, as you see in the map. In addition, there are preliminary results from genetic analysis, which are not yet published, which indicate that Italy also forms a distinct genetic group, and in Serbia, maybe even in Serbia, but that's not yet clear. Looking at expansion rates, the observed sigmoidal pattern appears to be plausible because it's very well known in invasion biology as a pattern of species with very strong dispersal capabilities, like, for example, large flying insects, like our bee. And the high expansion rate of up to 90 kilometers per year can also be plausible if you look at other bee species where we know by experiments how far they can fly. Orchid bees have been shown to cover up to 95 kilometers. So I think we can safely say that our approach with sequentialist cost modeling is able to fill that knowledge gap if genetic methods are not available or not yet available, and hence can support decision making to develop management strategies and to support research on biological invasions. I would like to see that applied to other species to find out if this approach is applicable or is of broader applicability, or if this was just a lucky strike. Also, I think we could more or less easily extend the model from retrospective to predictive modeling. Because what invasion biologists keep asking me is, okay, nice, but when will it be where? For everyone interested in more information and proper graphics and proper tables, I recommend reading our paper in landscape ecology and visiting my GitHub repository. There you will find all program code and a Jupyter notebook which allows you to play around with my code. Thank you.
Okay, thank you very much, Krista. I'm sorry for some technical glitches, but I think your message came across very clear.
I hope so.
So thank you for your effort in going all the way to the end. We now move to Daniel, to Dui Nguyen, who was also the recipient of the second prize. Daniel was a student at UNIGIS Amsterdam. Daniel Nguyen is a senior ESG controller at the Vian Food Group, responsible for driving the development and optimization of data and system components for ESG reporting at the corporate level. His work focuses on applying frameworks such as CSRD to deliver transparent information for internal and external stakeholders, as well as reliable management insights for corporate decision-making. He has built strong expertise in ESG data governance, including data collection, validation, consolidation, risk and control, and process optimization and automation. Alongside his sustainability role, he pursues his interest in spatial intelligence, applying methodological frameworks and mathematical optimization to decision making. His work highlights the opportunity to leverage proven geospatial techniques on Earth to support high-stakes decision-making in extraterrestrial environments where empirical data is scarce and uncertainty is high. His thesis is entitled Extraterrestrial Potato: Mapping Suitable Cultivation Sites on Mars Using Geographic Information Sciences and Multi-Criteria Decision-Making Methods. Let's hear Daniel. Daniel, the floor is yours.
Thank you, Marco, for the introduction and for having me in this occasion. And depends on where you are. Good morning, good afternoon, and good evening. So I'm very honored to present to you today my master's thesis titled Extraterrestrial Potato: Suitability Analysis for Suitable Cultivation Sites on Mars. And this research was done under the supervision of Professor Wim van Vestrenden. He was instrumental to my research because he could help bridge the principles within the research between the complex multi-criteria decision-making and the harsh realities on extraterrestrial bodies. So let's begin. In their essay titled Why Explore Space?, the European Space Agency stated nearly all successful civilizations have been willing to explore. That same spirit has driven the evolution of life on Earth, has driven us to explore our own home planet, has driven us to the moon and back, and further to visit the stars. And through this journey, the innovation that we have learned and brought back to Earth has helped us from clean water to solutions we use in in-house care these days. And on top of that, it also provides us an opportunity to gain more perspective and science to understand our origin, our cosmic role, the climate on Earth, on other planets, and also sustainability itself. But as we go further, we need to always consider three of the major foundational building blocks: the energy it would take, the mass, and the space that we carry with us. And what enables us, one of the most important components, food, at one point becomes our bottleneck, our limitation. With this rate of our engineering and science, the further we go into space, the more food we need, the more we need to carry, and hence the physical limitation. So one of the directions that we would like to explore is to look for an intermediary along the way of our journey to start and build cultivation sites or habitats. Our prime candidate at this moment is Mars because of its proximity, and potato is one of the crops on the short list of crops with potential due to their yield and nutrition, which have been studied and experimented for decades by our scientists to figure out the feasibility on these environments. So the question is not only to figure out if we can plant somewhere, but when it comes to this kind of decision, we need the location component. So where is the most optimal place to start? And that was the reason why I continue with these research questions. What are the most suitable locations on Mars for establishing the first potato plantation sites with a combination of GIS technology and several principles, namely AHP, Analytical Hierarchical Process, thesis, Monte Carlo simulation, and also global sensitivity analysis. They will all make sense in the coming slides. Now, before we dive into the complexity of calculations and math, let's bring this back to what we could relate in life on Earth. Let's start with the fundamental questions, or classic one, so to say. Select a place for dinner. Perhaps this is a very common decision, and for that, we have several criteria to make that decision. You may care about the style, the location, the price, mobility, infrastructure, and you may assign to each of these the relative importance. Maybe the style is very important because that day you want to try something specific and you don't care much about the price. That step in the process is the HP itself. And right after that, when you score the data that you've gathered for these criteria against themselves and try to rank to figure out the most suitable solution, that's when the fuzzy thesis comes. So what's the catch? Here's the catch. When we have made that decisions, perhaps some days or some time, we would like to consider some other options. Suddenly, some priorities shift. For example, price normally is a very unimportant factor suddenly become very important. For example, the end of your pay slip of this month, you may need to consider that with higher importance. So when you increase such weight, what would happen to your outcome? That's where global sensitivity analysis come in, to see with small tweaks here and there in your criteria how the outcome would be affected. And then afterwards, you would like to see how robust your model is. If you apply this kind of reasoning, if you just randomly select a place, would your model still hold? And 1,000 runs of multiple scenarios were done in Monte Carlo simulation. Applying the same principle of selecting a place for dinner to Mars, we examined about 750,000 alternatives, 16 layers of global raster data, namely terrain and thermal layers, nutrition layers, and also dust abundance layers. We are left with about 10,000 candidates location. So what's the result after that? After all the ranking and assigning weight, we overlaid the final output of 10,000 candidates to the perchlorate layer. Essentially, this is a very toxic chemicals for life. So if you see it, it's very harmful. But that's why in the end, we overlay the 10,000 ones with the perchlorate layers. We come up with the final list. And for ease of visualization to examine further, here you can see the top 15 recommended areas on Mars. And what you could notice is within this map, I also show the areas that NASA, ESA, and the UK Space Agency have great interest in for their missions, especially the missions related to biology, chemistry, and further exploration of life on other planets. So this would also support strategic planning in the future. Instead of knowing only one option, now you know if you want to extend in the future, what would be the next in line. And a bit on the validation side at this stage for the model, we could see that it's very stable at 99%. Only dust and silicates would cause very minor shifts in the outcome. And when it comes to robustness itself, when we introduce uncertainty, it could perform and produce a match of 84.4%. And that is very promising results. The criteria that cause such high variance in the model itself turn out to be amphibole layer. Amphibole is a rather high important or high priority when it comes to these layers related to nutrients. I'm going to circle back on that, how we would tackle that in the discussion. When we zoom in to the top 5 selected area, let's say for a mission of several years, and we want to stay there for longer term, then rank number 1 would be around Dagria, best overall for harming the objective of our research and protection, of course. And close to that is the nutrition-rich volcanic soil area of Amethyst Planum. Then we would have other three candidates with stable soil and for early growth, good thermal moisture retention, and also good for control system close to the area around the ExoMars rover of ESA. We have come to our discussion. So when we've been through with the research and look back at our research itself, it was really obvious that due to the global focus at that moment, the course level data that we gather could accommodate the calculation in the output. However, when you actually plan for a realistic mission in the future, you would want to know with very high precision where to land, where to set up habitat, where to begin your first plantations, and for that purpose, we recommend high resolution. In the future, what we would also want to see is the inclusion of fuzzy logic in the AHP step. That's very simple for a mission to have a lot of different stakeholders with conflicting objectives, and using fuzzy logic in the AHP state would allow you to include all of the inputs from the different teams and improve decision accuracy. And if you remember earlier, I mentioned the amphibole layer that causes really high variance. This is one interesting point that we notice. In the model, only this layer shows the characteristics of a very high priority layer, but then the distribution is rather scarce. So whenever I detect a certain amount of the amphibole itself, it will screw the output. And being conscious of them, I just would like to share my parting words. In the end, it is more than just potato on Mars. This research has shown how we could use Earth-proven methods, science, and data to make decisions in unknown environments to further our explorations. And if there's one thing that I could leave you with this presentation, it is to explore. You would be amazed where it would bring you. And dream on. With that, I would like to hand the floor back to Marco.
Thank you very much, Daniel. Our final presentation is from José Carvalho, the first prize winner of this year. José was a student at UNIGIS Portugal. José Miguel Cordeiro Carvalho holds a bachelor degree in computer science from the University of Chile and a master's degree in geographic information systems and science from Nova Information Management School in Lisbon. He currently works as a machine learning engineer, combining his expertise in software development with geospatial knowledge. His academic research explored the intersection of artificial intelligence and GIS, investigating how large language models can help bridge the gap between users and spatial data. For his master's thesis, he developed Prompt-to-Map, a system that converts natural language queries into interactive web maps using LLMs and retrieval augmented generation techniques. Let's now hear José's presentation. José, the floor is yours.
Thank you very much, Professor Marco. Well, good afternoon, everyone. As Professor Marco already said, my presentation is focused on this tool that I built for my master thesis called Prompt-to-Map, which goal is to generate maps or aims to generate maps based on natural language questions. So let's start. I chose this quote to start with because it represents a bit of my interest in the subject of why it's important to bridge this gap between non-technical and technical users. And it reads like this: drawing a map implies a degree of political and scientific mastery over the space represented, and it's an instrument of power over that space and the people who inhabit it. This means that basically making a map is an act of power. And if that is true, democratizing the access to maps is a way of democratizing power. So that is my main motivation. Okay, let me talk a little bit about me. As Professor Marco also said, my background is in software engineer. I have a bachelor in computer science from Chile. I know many people start in GIS and then move to software. I am doing quite the opposite path. I am starting from a software background and trying to move into GIS because I think that the space is very important to understand the data and the work itself. And my main interest is building tools that may allow more people to ask interesting questions about the world and answer questions using, in other things, maps and cartography. So today I'm going to talk about these 6 things. First, I'm going to mention this gap that we talk about technical and non-technical users. Then I'm going to present the key technical concepts which are used in my solution, in my project. Then overlay all the architecture of my project. Then some examples. Then the evaluation of this tool, and finally some risks and takeaways. So let's start with the gap. I think that today we live in a kind of paradoxical situation in which more than ever we have access to tools to map, to download data, special data from the internet. But on the other hand, GIS itself requires a highly specialized knowledge. I mean, you have to master a tool like QGIS or programming. So there are barriers, let's say educational barriers, technical barriers that prevents the full democratization of GIS, in my opinion. And this is where the concept of a self-service GIS comes. This is a concept that was invented by Roland and co-authors in 2020. And it's the idea that if you have spatial data, you should allow the user to ask the questions and try to interact with that data without having to have a technical person in the middle. And well, this was before ChatGPT and all the large language model hype. But I think that 2 years after that work about self-service GIS, large language models, including ChatGPT and other kind of chatbots, open a path in which natural language could be that interface between the non-technical user and the GIS systems. So let's say that 25 years ago, all these desktop GIS tools like ArcGIS, QGIS were invented. And then the things haven't changed that much. But I think that in 25 years, by 2050, things are going to be very, very different because of the impact that large language models will have into the process of how we make maps. So I'm going to go into that. So I had 3 objectives with this research. The first one was to build a system that converts a natural language query, or a question if you want, into an interactive web map. That was the base of this project. Then, secondly, was to evaluate that. I mean, how accurate that system could be, have some metrics that could assess that. And then at the end, examine and analyze what implication this kind of tool has for GIS practitioners and for non-technical people. So, concretely, let's say I have a question like, what is the population density of the Lisbon parishes? Just a note, right? Parish is like a commune or a county, if you want. But it's basically like, if I want to know the density of the population of a city, and I have the data to do that, I have, let's say, a census data, these 2 elements combined should be enough to create a map, an interactive map. Today, in order to do that, I will have to do several steps: downloading the data, cleaning the data, eventually geocoding or doing some kind of like processing of the spatial side of the data, writing SQL queries to have the data answer a specific question, doing the map, the styling of the map, resolution, all kind of things. And my idea was, okay, with these new tools, with the AI, can this be like streamlined in an easier way? So this project has 4 building blocks. The first of all is large language models itself. It's these big neural networks that understand, in quotes, and can like translate natural language into other things. We will see that. But basically all the ChatGPT and similar models. The second one that is related also is a technique called retrieval augmented generation, or RAG. That is just a technique to give more context to the language models of information that might not be part of the training set of that model. The third block, that I think is the most important one, is text to SQL on Spatial DB. SQL is just a language that you can use, like a kind of like a programming language that you can use to access data in a database. And if the database has special procedures, special functions, that SQL can also make special operations. So if you find a way to translate a natural language question into a SQL query, you can do a lot of things in terms of spatial processing and in terms of retrieving data. And finally, is what is called as tool or function calling. That is the ability for large language models to not only like to do a reply response, but also to call some external tools from the world. I mean, it's like the ability of a language model to act in the world at the end. But we will go deep into these 4 building blocks. So as I was saying, a standard large language model flow is like this. You have a passive chatbot in which you ask a question. The chatbot has some training set in which it has information that could answer, or you could use RAG in order to get more information, doesn't matter. But then you have an answer, a text answer. My goal was to build something like in the B case, that is, you have a question, and the large language model works as an orchestrator in which it queries the data that it needs to answer the question, it calls the tools it needs to map the data, and the output, the result, is a map. Okay, I'm going to stop here a little bit because this is the architecture that I am proposing in order to achieve this. First of all, we need to have a prompt. A prompt is basically a question, something that you want to know about the world, and something that you want to know that has a spatial dimension that can be mapped. Then we have 2 components here. The first one is the retriever, and the second one is the generator. The retriever is the one that I already mentioned that can translate. It's basically a translator. It translates your question into a SQL query. And the SQL query is going to allow you to retrieve the data that you need to map. Besides the question, you have to have 2 other things. First, you have to have a special data source. I mean, all of this architecture and this project doesn't search the data into the internet. You already have to have a curated, clean data set in order to ask questions over it. And then you need to have metadata. Because if you have a data set with columns, you need to explain to the large language model what each of the columns means. Basically. And then with that SQL query, I can go to the special data source and I can retrieve what I call here a spatial data frame. But it's basically a set of rows that has also a geographical feature attached to them. It could be points or polygons, etc. Then, okay, so I already have the question, I already have the data. Now, how do I map this? And there is the second part of the process, which I call the generator. And the generator basically calls a tool, an external tool. In this case, I'm using Folium, that is a Python library that is used for mapping, but it could be like any kind of like mapping tool. It could be even like QGIS. It's basically the process, the tool calling is the process in which the large language model calls the mapper. The mapper does its job in maps. And then the output of both things is the map. Okay, this is something that I get asked frequently, so I want to clarify. When people ask, is this an agent, an AI agent? It's like hype of the agent, what is an agent? And I like this definition. This definition is from Hugging Face. Hugging Face is a big open source platform of open models. And they say they define agency as not as something that is binary, so that you are not an agent, but as an spectrum. So you have in one side a plain large language model that you chat and it has text answers, and in the other side you could have a multi-agent with several large language models talking between them and calling external tools. But in the middle of that you have a lot of intermediate agents with some level of agency, and these tools is right in the middle, in which the LLM can ask some external tools, so you can act in a limited way in the world with this thing that we call tool calling. Okay, this is more from the part of the implementation, because each of the boxes of the architecture can be mapped into a specific technology. You have to choose a technology to map, you have to choose a technology to do the LLM, but many of them are are just the choices that I did, but they could be other choices. For example, I'm using for spatial DB DuckDB, but I could have been using PostGIS, other technologies. I'm using the OpenAI API, but I could be using Anthropic API, doesn't matter. But these are the specific tools that I choose in order to implement this. And let's see some examples. To test this, I chose the Portuguese census of 2021. I think it's an interesting dataset because it has a lot of variables and 3 spatial levels, like the parish / commune level, the municipality level, and the council level. So you have 3 different levels that you could ask different questions. So let's see some examples using this dataset. The first example is about the difference between young and old population. This is an information that is part of the census, of course. And the question here is, I want to map the young to old ratio per municipality. So basically, the higher the ratio is, the more young people per old people there are, and the opposite. The lower the value is, there are more old people than. And if you see to the right, this is the output, the actual output of the package. And you see, well, there's a nice, interesting spatial pattern. But the interesting thing is that the process itself can do, first of all, identify what are the columns that are needed to answer the question. In this case, n individuals, etc. Then do the spatial grouping that is needed, because the data is in the lowest level of granularity, is the parish level, and I have to do some spatial aggregation in order to map this. This all is embedded into the SQL query. And then finally, use a choropleth map in order to display the data to the user. And this is an interactive map, so you can hover into each of the municipalities and see the actual value. So this is a first example. Another example is regarding unemployment, for example. The prompt here was, what is the unemployment rate in the parishes of Lisbon municipality? So this, as a whole, this is one municipality, but the municipality has several parishes. And the same, I mean, the software in doing this translation to SQL gets the columns that are important, does some kind of ratio probably, and then displays the information into the right level of resolution and etc. So when I developed this, I thought that the main user was, because you could ask me, why is this needed? If you have Cloud Code, you can just put everything into Cloud Code, and Cloud Code could generate a code that does this, and that is true. But for example, if you are a census or a statistics bureau, if you are an agency that produces data and you want to make that data closer to the end user, let's say journalists, common citizens, then these tools is very useful because you are offering a new interface at the end. So you have to have the spatial data already curated and rich, but you can give a new, as I say here, a new front door to that data in order to make the data closer to the people that is represented in that data. That is the interesting part. So I'm thinking on Census Bureau, on health, public health institutions. This for epidemiology, for example, could be very, very useful, and so on. That was my idea at the end. But of course, this is open source, so everyone who has a different idea could use this in a different way. Regarding evaluating this is, I think, generally in machine learning, I think evaluating is the hardest part of every problem because you have to choose a right metric. And here, in order to evaluate this, you have to you will have to have like a representative sample of data sets and a representative sample of questions, and that is just impossible. Right? So what I did is I stayed in the census data, and I selected 3 metrics. The first one is an F1 score. So basically, I just defined 10 questions, which I already knew the answer, and then I just like run the model and see like if the output of the prompt to map was using the same data as I thought that it should be using. So it's a measure between the similarity of the data, of the expected data, and the similarity of the expected data and the data that the model uses. And the other 2, the consistency entropy and mode frequency, are related to consistency. Are related to this has to do with the fact that LLMs are not deterministic. So if you ask the same prompt 5 times, 10 times, the answer might change, and I don't want that. I want it to be as stable as possible. So I also run this like several times for the same prompt in order to know like how different results work. Let's go with some medical considerations. These are like this from a previous work that wasn't using ChatGPT. It was from a model that was called DALI. I don't know if you remember, a model that generated images from prompts. And these authors, what they did was to generate maps with that model. And they focuses on this potential like problem that these models could have in terms of inaccuracies or misleading information. If you see the number 1, 2, and 3 are basically inaccuracies or things that are not what they should be. For example, if I ask a question regarding Lisbon and the SQL query is not 100% right and there is a problem with the word clause, there is some kind of problem, the data that is going to be retrieved is going to be bad. So the map, it will be a map, but the map won't be the map that answers your question. And if you don't know what is the answer to your question, you won't know that. You won't know that. And that is very complicated because you are like misleading the users. So that is like a big concern in terms of like hallucination. Also it has to do with that, right? With like inventing, like for example, inventing parishes that don't exist. That is possible. And the other thing that I was really concerned was number 4 with the reproducibility. That was the thing that I was saying before, like guaranteeing that running this multiple times will give similar or the same result idea. Those are the more important things. Okay, well, regarding the project itself, this is all open source, so I invite you to visit my GitHub repository, to download the package, to mess with the package, and I also prepared a live demo that I can't like show today, but if you want later, that is the link, censusmapgpt.streamlit.app. But all the maps that I showed before can be generated and were generated through that app. So please, like, if you want, you can test it. So just to finish, my main 3 takeaways are: first, LLMs are going to reshape GIS for sure and for better, I think, because we are going to spend less time like dealing with the data and doing transformation and more time thinking and doing spatial analysis. Secondly, the AI and large language model can close this gap between technical and non-technical users. And finally, there are risks that has to be taken into consideration and must be mitigated, of course. There are my 3 main takeaways from this project, and here are the reference of my thesis. Of course, there are more, but you can see the document. Like I think it's published on the internet. So if you want to see like a more deep dive into this, be welcome. And that's it. Thank you very much. Any question, any ideas, or how this could be integrated into some place, please talk to me. I have my email, my LinkedIn profile, etc. And thank you very much for your attendance. Thank you.
Well. Okay. Thank you very much, Joseph, for your presentation. I thank the 3 speakers. As the audience can see, 3 very different aspects of our geospatial sciences, and I think also 3 very inspiring presentations. We can move now to the Q&A session, which is a great opportunity, of course, to explore sorry, I had an interruption here. It's a good opportunity to explore their work in more depth. I encourage everyone to ask questions, share your reflections, raise ideas sparked by these presentations. Please feel free to use the chat and let us know your ideas and your questions. I also encourage the speakers. I noticed that some of you, or I guess the three of you, you have links to your work. So if you want, you can share your links in the comments so that the audience can also use those links. Okay, while the people attending think about their questions, maybe I'm going to ask a question to each of the speakers, and then we can move on to those questions. So I will ask a question to Krista. Krista, in your thesis, you used a least cost modeling to reconstruct potential pathways of introduction and spread of your invasive wild bee species. And so you highlight the possibility of multiple introduction events. So considering your findings, how could your approach support current biodiversity management and biosecurity strategies, like for example, in improving early detection, monitoring, or prevention of these invasive species?
Good question. I think that one important potential use is in the research itself, in innovation biology research. Given that genetic methods are labor-intensive and expensive and often not available at an early invasion stage, or not available because the species does not cause any economic harm, then the spatiotemporal methods can inform genetic sampling and inform the research process to target monitoring, to target genetic sampling. I think it can make innovation biology research more efficient. You're muted.
Thank you very much. Now we have a question for Daniel. So Daniel, in your thesis, you developed a geospatial approach that identify suitable locations on Mars for the potato cultivation. And you used environmental variables and spatial modeling techniques to achieve your objectives. So while your context is really outside the Earth, it's extraterrestrial, how do you see your methodology contributing to current challenges on Earth, such as food security, agriculture in extreme environments, or climate adaptation?
Yeah, that is a very profound question, and to be honest, that was also a very major driver to my research, because essentially the framework was created to see if it could work on environments where we have to deal with great uncertainty and data is rather scarce. So if we step out of Mars context for a moment and we look at Earth, there are a lot of areas on Earth that match those descriptions. That's first, and then there are a lot of initiatives on Earth about food, about crisis response that could use this model. So for example, if we think about marginal lands in the region of Africa, in the region of Chile, or where farmlands being degraded around South America, the model would be able to pinpoint the areas where we cannot say with 100% certainty whether we can plant something on it or whether we can invest in the land or not, but provide a probability for the decision makers, for the farmers to say, okay, how much do we want to try with it and whether there's a chance for success or not. And for climate change adaptation, the model is rather flexible and it's dynamic. So in the future, whenever there's any change in variables, let's say change in temperature, we could prioritize temperature a bit more by increasing the weight, for example. So if we apply it on Earth, those are the situations I would expect to see the framework being effective and utilized.
All right, thank you very much, Daniel. So for Jose, there is a question from the audience, which I'm going to read out loud. Thanks. What is the technical background of your tool? So you briefly mentioned Claude. However, to use the Claude API for agentic use of text in SQL for the retrieval part, this costs quite some money. How did you implement agentic GUI in your thesis?
Well, thanks for the question. Actually, this uses like a plain large language model API. I was using OpenAI API, but I wasn't using any kind of like specific text to SQL like model. I just like did my own like parser in order to prompt engineer the question and then convert it and then parse again the result into the SQL query and then do some kind of like fixing into the query in order for the query to work. So there was a lot of like prompt engineering, but the idea was this to work with any large language model. So it uses the OpenAI API, but if you use like something like LM Studio or another, there are other like providers that are also compatible with that API. So it doesn't depend specifically of ChatGPT, it will be another API. But of course, if you like switch the model to a better like text to SQL, it will be even better than the tool that I have now. So yeah.
Okay, thank you very much. So our time is coming to an end. I really would like to thank and congratulate again the speakers for their achievements, for their presentations, very, very clear presentations today. So thank you very much for being alumni from UNIGIS and hope your future lives will go well. There is okay, I'm going to take this last question for Krista. Krista, can you read the question in the comments? I'm going to read it out loud. Would your work be easily applicable, transferable to other Hymenoptera species? Okay, I am thinking of Vespa velutina. Okay, so go. Can you say something about that, Krista?
Yes.
Before we close down.
I'm smiling because Vespa velutina is really well, highly researched right now, and I would also love to try it with Vespa velutina. I think it's a similar kind of species like my bee. It's also a large flying insect, and I would expect to work the methodology similarly well because it's the same kind of species. But as it's a data-driven, well, not the same kind of species, it's the same type of behavior. But as it's a data-driven method, everything depends on the quality of your input data, of the observational records. I was very lucky to work with the database of the researcher Julia Lanner. It was a very well-curated database with observational records. So if you have good input data, which is curated, I think you can expect the same quality of results with Vespa velutina. I would love to see that.
All right, Krista.
I hope this answers the question.
Hopefully so. Yeah. So thank you very much again, all of you. I also let you know that the session today will be published on YouTube. I will send both the speakers and the attendants the links in the very near future. Okay. So thanks again for the viewers for attending. We'll be back in our regular series on May 27th at the same time with a new topic. So on May 27th, we'll be talking about marine data enabling digital twins of the ocean. Okay, so have a great afternoon and see you all soon, I hope. Bye-bye.